This is an agent loop. It sends a job to the model, runs whatever the model asks for, and feeds the result back. Then does it again until it finishes the task. That's the whole idea, and we'll build it ourselves this episode. Quick orientation. This is a 6-part series, and we build one agent across all of it, adding a single idea per episode. Today is the smallest version that still does real work. A loop and one tool. Everything that comes later. Tools, compaction, memory, skills, multiple agents, is machinery we wrap around this loop. And so in this video, we're going to get the loop right. There's one piece the loop needs that we haven't named yet, the tool. Tools get their own episode, but the agent loop needs at least one. So which tool should we use? For this build, the tool is bash. That means the model can ask our program to run a shell command. Basically the same kind of command we would type in a terminal. And because it's a shell, that one tool can do a lot. List files, search text, run scripts, run tests. It's powerful because the agent can write a command, run it, see the output, and decide what to do next. And that's also the risk. The agent could do things outside of our project, delete files, modify the wrong folder, or run programs we didn't want it to. So we tell it to do all its work inside the throwaway sandbox folder. The agent's work should stay inside that folder. But that's just convention, not real isolation. Each command does start inside the sandbox. But nothing stops the model from writing cd ... or an absolute path in a single command. It has a real shell. So if you run this on your own tasks and repositories, run it inside a Docker container, or on a machine you're willing to wipe. Later in the series, when we put this agent on the benchmark, that's exactly what we do. Every task runs in its own container. Now let's map out what we need to build. Here are the 5 pieces. First, imports and setup. No heavy dependencies here, just the small set of libraries the loop needs. The setup part is where the model key comes from, so the agent isn't hard-coded to one provider. Then one tool, bash. We're keeping it deliberately small today. Episode 2 is where tools get interesting. Then the prompts. The system prompt, with the agent's standing instructions, and the task. One clear job to work on. Then the loop itself. Call the model. Run a tool if it asks. Feed the result back. And stop when there are no more tool calls. And finally, main. The entry point that sets everything up and hands it all to the loop. That's the build order for our agent loop. One expectation to set before we get into the code. Across this whole series, we walk you through the core pieces and stay at a high level. We don't explain the code line by line. The code is well documented, so it's easy to follow on your own. Also, every episode ends with a small lab. Do those and more. So don't just watch these videos. They are the reference. The real learning happens when you engage with the code yourself, run it, and experiment with it. We are now in the code repo. Here's the repo URL one more time. Clone it so you can follow along. The main code lives under episodes. So let's go in. Open up the first episode folder. And there's the agent.py file we need. The code in this file maps to the 5 pieces we just saw. Let's place that map right along the bottom so you can follow where we are. It's a fair bit of code. So let's zoom out a little. One more thing before we dig in. This file has a lot of comments and doc strings. Great documentation for reading on your own. But right now, they get in the way. So let's tuck them out of view and keep just the core code. Now let's review the code. First, the imports. The small handful of libraries the loop needs. Nothing exotic. Then the model setup. This function picks the right API key from your env file, based on the provider. Then it builds the client that we use to make model calls. You can swap providers in your env file, change one line, and this agent file works the same. Then our one tool, bash. It's a function, and it takes the command as a string. That could be any bash command the model comes up with. Then we open a sub process. That's how Python runs that bash command for us. And notice cwd equals sandbox. Every command starts inside that one throwaway sandbox folder. And this try block, this is where the command actually runs. If it finishes, we tidy up the output. Trim it, cap it at 20,000 characters, so a chatty command can't flood the context. Note the exit code if it failed. And return it all to the model. And if it hangs, the accept path takes over. Kill the command, and hand the model an error message instead. so it can adapt. The killing itself happens in this helper function, kill process tree. We won't go through that one. It's boilerplate cleanup for when a command goes wrong. And this dictionary underneath is the schema for the tool. Here's why it exists. The model never sees your Python code. It only sees what you send it in the API request, so you have to describe the tool explicitly. Its name, what it does, and the one argument it takes, a command. The model uses this to decide when to call the tool and how to format its request so your code can parse it. That's the contract between your program and the model. The structure looks verbose, but it's always the same shape. You copy it, then update the name, description, and parameters for each new tool. After the schema is defined, we create the tools list and pass it our one and only tool. In the next episode, we add more tools, so this list will grow. Next, the system prompt. The standing instructions the agent carries into every task. The system prompt is set up in its own markdown file. This one line reads it in. In the last video, we said we'd get a good look at this file. Let's open it. It starts with the role. You are a coding assistant inside a working copy of a repo. You will be given a task. Carry it out to completion. Then the biggest block, verification rules. Like this first one. If you change code, you must run the project's own test suite before you give your final answer. And a few rules on change hygiene. Prefer the smallest edit that fixes the issue. Clean up your Scratch files. We won't go line by line here. Take a few minutes and read this file yourself. Every rule in it was earned the hard way, on real-world repos. At the end of this series, we'll show you exactly where these rules came from. For now, back to the agent. Here's the main user task, the job we hand the agent to complete. Right now, it asks for a summary of the project. And notice there's a second task underneath. Comment it out. We'll come back to these tasks in a minute. For now, let's continue with the rest of the script. There's a little telemetry in the middle. This part records every tool call the agent makes in order, so we can see the path it took. And this part records the token counts for the run. We'll come back to both of those numbers later. And now, the loop. The same loop from the opening scene, now in Python. It lives in one function. Run agent, and check the signature. A client, a model, a system prompt, tools, and a task. This function is self-contained. Import it anywhere, give it those 5 things, and it returns the final answer. Let's focus on the main code for the loop. I'll hide the lines for logging and metric tracking. That leaves the core. Let's walk through it. First, we initialize the messages list. That's the conversation. It starts with just 2 entries, the system prompt and the task. And then we enter the loop. We make a call to the model, send the whole conversation so far, plus our tools list, which contains a single bash tool. The model sends a response back. Then we look at that response. If the model asks to run a tool, we run each call. And then, this is the key part, we append the result back into the messages list. That one line is what makes this a loop, rather than a one-shot call. The model's next turn sees the tool output as part of the conversation history. That's how it knows what happened, and what to do next, and we repeat the process. When the model doesn't ask for any further tool calls, we're done, and the function returns the final answer. So that's the entire loop, and the append is the heart of it. Let's bring back the lines for logging and metrics. One question left. Who calls this function? Let's look at that next. At the bottom of the script, we have the main function. This is the entry point. First, the sandbox reset. Every run, we clear out the contents of the sandbox folder and copy initial into it, so we have a fresh copy. Then the agent is supposed to do all its work inside sandbox. Then the model setup. Read the env file, pick the model, and build the client with the makeClient function we saw earlier. And then the handoff to the agent. We give it the client, the model, system prompt, tools, and the task. This one line runs the whole agent. And when it comes back, we write the bookkeeping files, the tool calls, and the metrics. So that's our agent, the whole machine, in one file. Take your time to go through this script and internalize what's happening here. The simple loop we see in this script is the mechanism that drives every coding agent. Now let's get to our actual task for episode 1. Here's the job. Explore this project and tell me what it does. And the rule is, respond in 100 to 150 words and base it on what it actually finds in the code. No guessing. And here's what we pointed at. A small project called MD2HTML. Markdown in, HTML out. Let's open it up. Just a handful of Python files and a tests folder. And notice, there's no README. No documentation in here tells you what this project is except for the code itself. The agent has to explore this codebase and tell us what it does. Okay, this is all set up. Let's bring up the terminal. And let me pull this up so we can see more of it. We already made the virtual environment and installed everything, so we can just run it. We are using the GLM 5.2 model, by the way, set in the env file. To run it, we go through the harness, run.py, with the -- capture flag, so the whole run will get saved. Before we hit enter, pause for a second. The only tool it has is bash. Do you think it gets this right? Hold that thought. Let's run it. And there it goes. This will take a while, so let's cut ahead to the end. And here's the finished run. Let's check the answer. This is the summary the agent gave us. It's telling us what the project is: a small, dependency-free markdown to HTML converter in Python. A 3-stage pipeline, lexer, parser, renderer. So it did summarize the project correctly. Not bad for an agent with only one tool. Down at the bottom is the bill for the task completion. It tells you the number of bash calls, model calls, and tokens in and out. We will look at these stats more closely soon. One more thing. Remember the -- capture flag? Everything this run did got saved. Look in the logs folder. There's a new run folder in there now, stamped with the time. And inside, the full terminal log, every tool call, and the token numbers. Let's look at the summary of what these logs tell us. Start with the answer. This is what it told us. A markdown to HTML tool, a 3-stage pipeline, some extensions, a test suite. The agent did give us a good summary. Now let's look into how it got there. Here's what the run cost. 6 round trips to the model, just 5 bash calls. Under 19,000 tokens in, under 600 back out. And here are the 6 model calls, 1 per round trip. The first 3 rounds are it just orienting itself. It first tried commands that work on Unix and Mac OS, but not on Windows. We ran this on Windows, so it adapted on its own. And that dare call in round 3 mapped the whole tree. Then it reads the code. And look at these calls. It chains whole groups of files into a single command. That's how 5 calls covered the whole exploration. Here's everything it actually read. 5 files, plus a quick look at the top of the lexer. And here's what it didn't read: the parser, the renderer, the entire test suite. The agent got the answer right, but it didn't bother going through the important files. Are you okay with that? If you were asked to summarize this project, what would you have done? So our agent did the task, but that was an easy one. Summarize the project. A judgment call, really. Nobody can say the summary is wrong. Maybe the agent just got lucky. So now we make the task harder. Same agent, same bash tool. But this time it has to write the README. What it does, how to install it, the architecture, how to run the tests. Before we run it, take a guess. Does it succeed or struggle with the task? How many tool calls will it need? Let's go find out. We are back in our editor. Let me tuck the terminal down for a minute. And right there, the 2 task strings. The summarized task we just ran and a second one commented out. Let's flip them. The new job is to write the README. Explain what the project does, how to install and use it, how it's structured, and how to run the tests. So let's give it to our agent. Bring the terminal back up. And the exact same command as before. Quick reminder, every run starts fresh. New sandbox and no memory of the last task. So our agent remembers nothing from before. Now let's run it. And there it goes. This will take some time to run, so let's cut ahead. It's done. Let's check what it says. The agent says the README is written and verified. We will check what it wrote soon. 37 bash calls this time. Remember, the summary took 5. And here's the bill. 38 calls to the model and almost 1 million tokens in for one README file. We'll dig into where all that went in a bit. For now, let's go find the file it wrote. The task was to write a README into the sandbox folder. Let's close the terminal. Head over to the sandbox folder. And there it is, a new README. Let's read what it wrote, and let's judge it against the 4 things we asked for. It opens with what the project is: a small markdown to HTML converter with a 3-stage pipeline. The second paragraph provides details of the project. Accurate. Installation, pip install dot. That's exactly right for this repo. It even documents the test extra. And usage. Every real flag is here with worked examples. Then a full architecture section, the 3-stage pipeline, and each module described. Even the extension system is documented hook by hook. This matches the code. And finally, how to run the tests, the 3 test layers and the fixture pairs. So the README contains all 4 sections we asked for. The agent did the job well, even though it only had just one tool to work with, bash. Next, let's look at how this run went. First, the bill for that run. 38 model calls, 37 bash calls. Almost 1 million tokens in for one README file. So what were those 37 calls spent on? 17 calls to orient and read, and 20 calls trying to write one single file. Here are those 38 model calls, one by one. The first 17, the reading. Everything after, the writing. The writing starts at call 18. It tries the way that works on Linux, and Windows says no. 6 fresh starts on the same file. Here docs, a helper script, little quoting experiments. Windows kept rejecting them until it found the approach that works. Small appends, one section at a time, with a placeholder standing in for the quotes swapped out at the end. So overall, after a bit of a struggle, our agent managed to finish the task. After the experiments, this is the part to remember. The loop worked, even with one blunt tool. The limits showed up in the writing step. More than half of the run was not reasoning. It was file write attempts. The agent knew what to do, it just didn't have the right tools to do it. Give the agent a real file writing tool, and that whole stretch can become one move. That is the pattern. Keep the loop simple, but give it sharper tools for the jobs it keeps struggling through. So episode 2 is tools. Not a new loop, just better tools for the same one. I'll see you there.